Good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and welcome to another GameMaker tutorial. Now, in this tutorial, I'm going to show you guys how to do some random level generation, and I know a lot of you are excited about this, but I've got a couple disclaimers that I need to tell you first. This is not a tutorial for beginners. This is an advanced tutorial, and you have to have a good understanding of loops, a good understanding of data structures like a DS grid, because we're going to be using a DS grid in this, and you also need to have a basic understanding of just programming in general inside of GameMaker. So if you don't have those, I'm gonna post some links in this video that you can check out that are going to give you some of those basics, and you can watch those they're kind of the prerequisites for this. The other thing is that there are already some other tutorials done on this, and one of them is done by my good friend Lewis Clark, and I'm going to post a link to his video. He doesn't use a DS grid, so if you want to learn how to do this with objects, you can. And finally, the last thing is that in this video, it is going to be a 3-part series. In the first part, I'm going to show you how to create the level inside of a DS grid. And then in the next part, I'm going to show you how to create a character that can move around in that grid with a view. And the character will collide with, the character will use the grid for its collisions, so that you only have to have a few instances. You don't have to have tons of instances inside of your room. This will optimize your game quite a bit. And then in the last one, I'm going to show you guys how to, it's going to be kind of a Let's Pixel mixed in with some programming, where I'm going to show you guys how to auto tile the room. Now, this is going to be, let me show you what it's going to look like real quick. So you can see right here, this is a project that I've been working on that uses this exact system. And you can see over here, I've got a really great frame rate. This is my average frame rate. And I've got an instance count right here. This is how many instances or objects are in the room. So there's only 4. But I can still collide with all of these walls like this. And this one actually has teleporting, so I won't be showing you that in this series. But you can collide with all of these walls, and it looks really, really nice. The auto tiling system works very well. And if I hit space, you can see that it will generate a new level for me. And you can get different levels every time you hit space. And they all look actually quite nice. They've got the rooms and then some hallways that you can move around in. So it looks really quite good. So let's get started. I'm going to close out of this, open up a project here, and this is basically a brand new project. We're going to create a couple backgrounds real fast, so we're going to call this one background floor. My nephew is mad. I don't know if you can hear him in the background, but he is not happy. He's like a couple weeks old. My sister's here. So we're going to set this at a width of 32 by 32. So do 32 by 32. And for the floor, I'm just going to do a green color that's kind of a little bit lighter. Like that. And these are just temporary because we're going to be doing background wall. These are just temporary because we're going to be doing an automatic tiling system later anyways. So I'm going to do the wall. It's just going to be a darker version of the floor. Like that. So we've got 2 backgrounds. One's for the floor and one's for the wall. Now we're going to create a new object. And this is going to be called level. And it doesn't need a sprite. And we're going to give it a create event. It's going to have one big giant create event. So that's what most of this video is going to be, is writing this create event. First though, we do need to create a few macros. Now if you don't know what a macro is, that's fine. I'll explain it real quick because they're easy to explain. A macro is like a variable that can't change when the game is running. So a lot of the time they'll call them constants. That's another name. There's a little bit of a difference between the name macro and the name constant, but they're quite similar. So we won't go into that. But we're going to create one called cell width. And we're just setting up the system so that you can easily choose your own cell width and cell height. And the cell width we're going to do is 32. And we're going to do another one, cell height, if I can spell it. And we'll do that 32 as well. And then we'll do another one. A DS grid contains, you can put whatever you want. It's basically just a grid of cells, and each cell contains a specific value. We're going to create some constants that will represent, that will just be numbers, arbitrary numbers. We could choose basically any number, but these numbers will represent the different cells in the grid. So a certain number will represent a floor, a different number will represent a wall, and another number will represent a void, which is just neither a floor or a wall. So we're going to do those. We're going to do floor, and I'm going to make it -5. I'm going to do wall and make it -6. Now I chose these negative numbers because I don't think they overlap with other negative numbers inside of GameMaker. GameMaker has like the negative, I think -4 represents no one or no object. So that's why I started with 5. And these just seem to work fine. So that we've created our constants, and now we're ready to start our level generation. And you should see, if you created those constants correctly, you can now type them and they show up as constants inside of your autocorrection. And this value is now 32. So cell width is also 32. So let's create the level. And I'm just going to double check, make sure this is recording. Okay, yep, we're looking good. And I'm going to bring my reference a little so I can see a little bit more of it too, because there's a lot going on here. Now what we do is we basically create a giant room or a giant grid. We fill it all with void cells, and then we go through and we have a little controller object that steps through the room and then randomly changes directions. And so it kind of just mines out the room with floor. And then we go through and we add in the walls around the floor. Afterwards, we kind of outline the floor with the walls. So that's kind of the overall algorithm that we're going to do. So first, though, let's resize the room. And I'm just doing this so that no matter what size our grid cells are, our room will adjust accordingly. And I'm just going to do room width equals cell width divided by 16 times 720. You don't technically have to do it exactly like this, but I found these numbers work quite well and give a nice effect. You could mess around with these if you want. Times 720. So we've resized the room. Now what we're going to do is we're going to set the grid width and height. So we're going to do var width equals room width div cell width. So what does that do? Well, the grid is going to have the width of the grid is going to be exactly the number of cells that will fit inside of the room. That's what this does. We get the room width and we call the div operator on it, which just divides it, but it also divides it as a whole number, so you never get so you never get decimals. And so we divide it by the cell width, and that will give us exactly the amount of cells that will fit horizontally in our room. We're going to do the same thing with the height. Equals room height div cell height. Okay. And then we can create the grid now. So grid equals ds grid create, and we pass in a width and a height, which we've already created. Width, height. There we go. We've created our grid. So you've created your room, it just doesn't have anything in it. So we need to fill the grid now. Fill the grid with the void. And GameMaker has a nice function that allows you to do that, which is ds grid set region. So ds grid set region allows you to set all of the tiles or all of the cells in a certain region with a specific value. So the first thing it takes is the grid that we're using. So we're going to put in grid because can't type. That's the one we created right here, grid. And next it takes two corners of the, you pass in basically a rectangle and it takes two corners of the rectangle. So this is the top left corner, which is going to be 0, 0, because we want to fill the entire grid. Now we want to do width -1 and height -1. Now why are we subtracting 1? Did I miss another? Oh, the last one's the value that you need to pass. So why are we subtracting 1? Well, the grid starts counting at 0. So if we have a width of, if our grid is 3 cells wide, but it starts counting at cell 0, then our third cell is actually cell number 2. So it's 0, 1, and 2. So 3 wide, but the last cell is number 2. So that's why I want to subtract 1 from both of those. And the value we're going to pass in is void. And you can see it's a constant, so we can just type it in. That's a lot more meaningful than if we were to type in -7, which is the same thing, right? If we look at our constants, our void is just equal to -7. But -7 doesn't mean anything. If someone's looking at our code, they won't have a clue what -7 means. That's why we're using constants. We can type in void, and that makes sense. Okay, we've got a void cell there. There's nothing there. Now that we've set the region, we want to randomize the world. This will give us a different random generation each time. So there's a function in GameMaker that's called Randomize, and this just, I'm guessing it probably gets the time and creates a new random seed for that. So really simple function. Okay, we're getting into the good stuff now. We've got our grid created. Now we need to create our controller. Now the controller is just going to be, you could do an object for it, but I don't think that's really necessary. We're just going to do a couple variables that keep track of information about our controller. So create the controller in the center of the grid. So we're going to do var cx equals width div 2. Var cy equals height div 2. So this is getting the width of our grid, and we're dividing it by 2, but we won't get decimals. It's always going to return a whole number. And that's going to be the controller's x position. And then we'll do the same thing with the height for the controller's y position. So we're creating the controller. I mean, we don't really create a controller. We just use some variables that determine where the controller is located. Now, the controller is going to have a direction that it's moving, but we're only going to move in 4 directions, which is going to be right, up, left, and down. And we're going to represent these with 0 being right, up being 1, left being 2, and down being 3. So we're going to do cdir, which just stands for controller direction. Well, let's do give the controller a random direction. And we're going to do var cdir equals I random 3. So I random is going to choose a random number, but the I before it means integer, which means it's not going to have a decimal value. So it's going to choose 0, 1, 2, or 3. Now we're going to create another temporary variable, and I'm just going to call this this one might not be, let's make it temporary for now. I don't think it needs to be an instance variable. So the odds variable for changing direction. There's a lot of ways that you can do odds, but I found this way is kind of neat, so I'll just show it to you. We're going to do var odds equals 1, and then create the level using 1000 steps. Now, so we've created our odds variable, and I'll show you how we use that in just a second. Now we need to actually create the level. We're going to actually step through the level, setting tiles or setting cells to specific values. We're going to use a repeat function, repeat, which is a basic loop, and all it does is it runs a certain code, whatever code's inside of it, as many times as you tell it to. And I've found that 1000 works pretty good for this tutorial. It seems like a good number. So we're going to repeat this 1000 times. The first thing we're going to do is place a floor tile at the controller position. So if you're using a DS grid, there's a nice little thing called an accessor, and I'll show you how you can do that. You can do grid, and then the number sign, and then you pass in the X and the Y coordinates of the cell that you want to set. We're going to do CX and CY, which is the controller's X and controller's Y position, which is currently in the center of the room. And then we're going to set it to whatever we want to set it to. So we want to set this to a floor, because we're setting a floor tile wherever the controller is. And this is called an accessor. You can also do this. You could do DS grid set, and then you pass in grid, and then you do the X value CX, and then CY, and then you do the value, which is floor. You can do it like that as well, but it's more to type out. It's easier just to use an accessor, which is this little sign right here, and that's just an easier way to do it, but you can do it whichever way works best for you. Now that we've done that, we want to randomize the direction of the controller, because we're going to move the controller now. And the way we do this is we create, we check our odds variable that we created. So we can do if irandom odds is equal to odds. Now that seems really strange. What does it do? Well, odds is set to 1. Irandom odds is either going to be a 0 or a 1, because it's going to choose a random value up to 1. And it's going to be an integer value. That's why we've got the I there. So we're going to have 0 or a 1. Well, if this random number that we're choosing is equal to odds, which is already set to 1, then we'll do this. So we have a 50% chance of doing this. There's either a 0 or a 1 to determine whether or not we're going to do it. If we do this, we're going to change the direction again. irandom 3. So cdir equals irandom 3. We're going to choose 0, 0, 1, 2, or 3 directions. And then after we do that, we need to move. After we do that, we need to move the controller. Move the controller. So we're going to move the controller every step so that it creates a new floor tile somewhere else. This part's a little tricky, and there's a lot of different ways you can do this, but we're going to use the length_dir functions to get an x amount or direction that we're going to move and a y direction that we're going to move. So we're going to call those var x_dir equals length_dir x 1, because we only want to move one cell over, c_dir times 90. Var y_dir equals length_dir y 1 c_dir times 90 as well. Now, why are we multiplying these by 90? Well, c_dir is either going to be 0, 1, 2, or 3. But those aren't actual directions. Those are just numbers. In order to get them into actual directions, so like from 0 to 360, we need to multiply them by 90. What does that do? Well, if we're at 0 and we multiply it by 90, we're still going to be 0. That's right. But if we're at 1 and we multiply it by 90, we're going to be at 90. If we're at 2 and we multiply it by 90, we're going to be at 180, which is left. And 3, we're going to be at 270, which is down. It's going to give us exactly what we need for the direction we're facing. Now that we have the amount that we need to move in our x coordinate and the amount that we need to move in our y coordinate, we can just add them. So cx plus equals x_dir. cy plus equals y_dir. And that's going to move our controller accordingly, either right, up, left, or down, depending on which direction we're facing. Now, last of all, what we need to do inside of this, we're almost done with this little section, is we need to make sure that we don't move outside of the grid. And the easiest way to do this is just to clamp the cx and cy. And I'm pretty sure I prevent it from moving. I'm pretty sure I prevent it from moving even 1 pixel to the edge, because we want to be able to have a solid object on the last pixel. Basically, it has to stay at least 1 pixel from the edge. It can't move into that last pixel on the edge. Or last cell. Technically, it's not a pixel. So make sure we don't move outside the grid. So a clamp is just a function that prevents a variable from moving outside of a range. So we're going to do cx equals clamp. You pass it the value, which is cx. The minimum value, which we don't want it to be less than 1. And then the maximum value, which is going to be width minus 2. Why are we minusing 2? Well, if we have 3 cells, we have 0, 1, 2. So our width is 3, but our last cell is actually 2. If we minus 1, then our cx will be able to hit the last cell. We don't want it to. We want to have that 1 pixel border around the outside edge. So we have to minus 2 from it. Then we could do cy equals clamp cy 1 height minus 2. Okay, and that should work. This is the level generation right there. Now there's a few more things that we need to do in order to make it so that you can actually see what's going on inside of this loop right here. The first thing we need to do is we need to add the walls. And there's probably a more optimized way to do this, but this is pretty good. So you're not really going to know. If you can come up with a better way to do that, that's great. But if you can't, this is going to work fine. Trust me. You saw the game. It was running nice and smooth. It's not going to take a long time to generate this level. So we're going to use 2 for loops combined together to step through each cell of our grid. So we're going to do for var yy, I'm creating these variables so that I can kind of read them, equals 1, yy is less than height minus 2 minus 1, sorry, yy plus plus. So we're stepping through the range of our grid, but we're leaving that one cell border on the outside. Okay, and that's stepping through the y coordinate. We need to step through the x coordinate as well. For var xx equals 1, xx is less than width minus 1, xx plus plus. Okay. Now we need to check to see if at our current location we are, basically we're checking for the floor, and then we're going to set the walls around the floor. So if grid, and we're going to use that accessor again, xx, yy, so our current location in the grid, equals the floor. So if we are a floor tile, we need to check and see around us, each square around us. So we're going to do if grid, use the accessor, xx plus 1, yy, that's going to be 1 pixel to the right of us, does not equal a floor. So basically, if there's not a floor to the right of us, we know there's a void to the right of us. We're going to set the grid, accessor, xx plus 1, yy equals wall. Wow, that was kind of complicated. And I've got an error message right here. You can see unexpected symbol in expression. This is a great learning opportunity. What's happening? Well, it's telling me line 51, position 26. So you can see I'm position 8. If I go over, 26 is right here. Well, that doesn't really make sense because that's not wrong. But you can see that it's got me close because right here I've got a comma where I need a semicolon. It's an easy typo to make. Sometimes the information that the error message gives you isn't quite exactly where the error is, but it gets you close. I mean, it told me 26 and it was actually at position 20, so that's pretty close. Closer than I could get. Now that we've checked to the right, we need to check to the left as well. So actually just copy this right here. Well, no, let's not copy and paste. I like to copy and paste normally, but a lot of people struggle with copying and pasting because it can cause errors. So let's type this out. If grid xx minus 1 yy does not equal floor. So we're checking to the left now. If there's not a floor to the left of us, grid xx minus 1 yy equals wall. Okay, set the wall. Now let's do up and down. We'll do down first. If grid xx yy plus 1 does not equal floor, grid xx yy plus 1 equals wall. If grid xx yy minus 1, so we're going to check up this time, not equal floor, grid xx yy minus 1 equals wall. We're surrounding our floor tiles with walls as long as there's not another floor tile next to it. That's what we're doing. Check for walls. add the walls. I'm just going to add a few comments here for readability. Now we're going to add another for loop. So we're going to loop through the entire thing again. And it's going to look basically like our last one. For var yy equals 0. The difference is that we're going to loop through the entire grid, whereas before we were just looping through where we had placed floors, and we were leaving that one cell border on the outside for the walls if we needed them. Yy minus height, yy plus plus. Let's loop through the x coordinates for var xx equals 0, xx is less than width, xx plus plus. There we go. Now we're going to draw our tiles. And this is basically the last part. So good job, you've made it through most of this video. Our grid is getting created, but we're actually not drawing. The grid exists, the data structure exists, but there's no visual representation of the grid inside of our room. So that's what we're going to do right here, is draw the level. Draw the level using the grid. Now we're drawing the grid with a visual representation in the room. So if grid xx yy equals floor, we're going to draw a floor tile. Else if grid xx yy equals wall, we're going to draw a wall tile. Draw the floor, draw the wall. There we go, looking good. Let's draw our floor tile. Tile, add, background floor, because that's the tile we want to draw. The left position and the top position are if your tile is part of a tile set. Ours is not, so we can just pass in 0 for both the left and the top. The width is going to be cell width. The height is going to be cell height, because that's how big the tile is, or the background. The X position is going to be XX times cell width. Why is that? Because our grid data structure is set up of indexes. So we have 3 cells at position in the second cell, which is actually, we start at 0 and then we go to 1. This is number 1. Now if we multiply 1 by our cell height or our cell width, then it's going to position the tile in the correct place in the room, because it's our second cell, which our cell width is 32 pixels. That's why we need to do the cell width and cell height and multiply it by those. Yy times cell height. Because these numbers are going to be 0, 1, 2, 3, 4, 5, 6. And if we draw all our tiles at 0, 1, 2, 3, 4, 5, 6, they're going to overlap and look ugly. We need to multiply them by the width of the tiles. And then the last one is the depth of the tile. We're just going to do a depth of 0 for now. Okay, let's draw the wall. Tile, and I want to make sure that you guys can see this. So I'm going to move it just a bit to make sure you guys can see it. There we go. There's the entire section for the draw tile, if, where we add the tile, if you need to pause and look at that. Background, wall, 0, 0, cell width, cell height. We can pass the same arguments in. XX times cell width, YY times cell height, and 0 for our depth. Looking good. That is looking way good. Hopefully this works. Now, just to make it to make the effect even better, we're going to add an event. We're going to add a key press event. We're going to add space. So key press space. and we're just going to restart the room. This will give us a new level, new generation. So room, restart. There we go. And we need to create a room. Now you can see our floor tile is lighter, our wall tile is kind of a little bit darker. I'm just going to go into our backgrounds. And first of all, I'm going to set the room of 640 by 360. It doesn't matter really, because when we create the object, it's going to set the room size. I'm pretty sure it doesn't matter. We might have to change that actually. Anyways, I'm just going to set it at that size. Now let's go into the backgrounds, and I'm just going to choose a darker green, the lower saturation. That's going to be the void. So we'll have the lightest green as the floor, the medium green as the walls, and the darkest green as the void. Let's run this and see what happens. Cross our fingers. We might get an error. Yep, we did get an error, so let's look at that. Oh, it's just a typo. I spelled height wrong. So another great learning experience. Let's look at this error message. Let's try and read it. If you've never read an error message before, they're actually not too hard to read. Fatal error in action number 1 of create event for object level. Okay, that's actually really useful. Open up the object. Here's the create event. Here's action number 1, because these are the list of our actions. Okay, we've got it. Push execution error variable get. So it's trying to get a variable, but it's having an error with it. H-I-E-G-H-T. That is not how you spell height, right? Now if we go a little bit further down into here, you can see it's at line 11. And it even shows the line right here. Grid equals ds grid create width and height. So we should be able to come to line 11 right here. Let's abort this. Line 11, grid equals ds grid create width and height. Perfect. There's a quick lesson on reading error messages. Just in case you ignored my disclaimer at the start and you're a beginner and you got an error message. And we got another error message. And I spelled height again. This one is ds grid set region. Okay. Well, should we just look real quick and make sure I didn't spell height wrong every single time? Okay, that one's right. That one's wrong. Oh my gosh. That one's right. There we go. Okay. Wow, I must have been having quite the typo issue there. Spelled height wrong a bunch of times. And yeah, we're going to have to, that looks good, but we're going to have to fix our room's width and height. So just come back into your room and set the width and height. I'm just going to set mine to 720 and 720 for the width and height of the room. When we create a view, it will fix this, which will be in the next part of this series. But there you go. You can see what happens, and this is what I was talking about earlier. We're creating the floor tiles, but when we get over here to the edge, the floor tile never goes to the last cell. And we don't want it to go to that last cell because we need that last cell to be able to draw the wall tiles. And that's really important. And you can get some pretty interesting effects with this random level generation. There's a few things, a few tips that I'll show you in the next couple of videos of this series where I can show you how to make it look even cleaner, just like that example that I showed you at the start. We can remove single blocks in it, remove those single blocks, and just kind of clean up the level a bit, do a few more things to make it look even nicer and seem more intentional and a little bit less random. But there you go. You've done your very first level generation. You've done it through a DS grid data structure. So congratulations. Hopefully this video helped you and that you learned something from it. I really appreciate you guys' feedback and support. So thank you very much. If you like this video, like it, share it on Facebook and Twitter. That always helps me. And I will see you guys later.